this computer. Yes. Okay.
Bonjour à tous et bienvenue dans cette vidéo où on va discuter la modélisation du secteur résidentiel dans LEAP. Chris va donner cette présentation en anglais parce que YouTube nous permet d'avoir des sous-titres en français. Pour activer ces sous-titres en français, activez CC et puis paramètres, sous-titres CC, traduction automatique et puis sélectionnez français.
Merci, Eleni. Can I start?
Yes.
Thank you. Hello, everybody. Welcome to this discussion about the residential sector. In terms of looking at greenhouse gas mitigation in the residential sector, there are four main sources. There is fuels that are used for cooking, like wood, charcoal, other biomass, and then fossil fuels like LPG or electricity. Using kerosene for lighting is a common source, and the consumption of electricity, when it's not produced from renewable sources, can also produce greenhouse gas emissions. In the LEAP modeling, this consumption of electricity, the emissions, are accounted for under electricity generation and not under the residential sector. And in some countries where there is intermittent electricity supply, diesel generators can be used to produce electricity. So these are the main sources that we're trying to model in the residential sector. The policies and measures that we may want to evaluate in the residential sector include the switching of traditional biomass stoves to more efficient biomass stoves, switching of households to use cleaner fuels, less polluting fuels like LPG and electricity for cooking, increasing access to electricity to reduce the use of kerosene for lighting, and improving the energy efficiency of electricity consumption, improving the efficiency of appliances that consume electricity. So these are the types of policies and measures that we might want to evaluate in the residential sector. The calculations to estimate the emissions are quite simple. We multiply the consumption of different types of fuels by an emission factor. So we have the activity variable times by the emission factor to calculate the emissions, and that activity variable is the consumption of fuel. The consumption of fuel is calculated as the number of households who do a particular activity, who consume that fuel, multiplied by the energy intensity, or the average consumption of fuel per household. The number of households can be calculated as the total number of households times by the percentage of households who use a particular type of fuel. And the energy intensity, the average consumption of fuel per household, can be obtained sometimes directly from energy audits or energy surveys, or it can be calculated from the national energy balance as the total consumption of fuel divided by the number of households. To develop a model of the residential sector in LEAP, the key things that we need to decide, or that we want to understand, is how we're going to disaggregate the households in a particular country. We could have them all together. Commonly, urban and rural households are split because the energy needs and the fuels consumed are often different. Or we could split it by geographic regions. We also need to decide how we're going to split the different activities that consume energy. We could split them by having all the activities together, so having no split, or we could have split activities. Commonly, this is cooking, lighting, refrigeration, air conditioning, water heating. These type of activities can be separated out. So we have two good examples here. In Ghana, they have a very detailed model in which households are split into 5 geographic areas, urban and rural households, and then further split into different urban areas and different rural areas. They also split their activities into 10 individual activities that consume energy. In Ghana, they've been working on this data set for 10 years and have energy surveys and energy audits that provide the information, the energy intensity in this level of detail. A second example for Cambodia is much more of a top-down model. They have 3 levels of disaggregation. They separate the capital of Cambodia from other urban areas and rural areas, but they don't have any separation of activities. All of the fuel consumption is grouped together. So those are some examples of how we can look at the residential sector. So what data do we have available for the residential sector in Mali? Well, we have international data. For example, the World Bank have data on the percentage of the population that are in rural areas compared to urban areas. So using this international data, we should be able to get an urban and rural split. We also have national data. We have 2 excellent demographic and health surveys from 2006 and 2018 that provide information on the composition of households and what type of activities they have. We also have the national energy balance for Mali between 2004 and 2016, I think. In the demographic and health surveys, the information that they provide is the total number of average number of people per household in Bamako, other urban areas, rural areas, and for the whole country. That's what's shown here. They also tell us the percentage of households that have access to electricity in those geographic areas. And they tell us the percentage of households who cook using different types of fuels and technologies. In our national energy balance, we have the total consumption across the whole country of wood, of charcoal, LPG, of kerosene, and of electricity in the residential sector. So Eleni and I have spent time trying to gather this information and use it to develop a model of the residential sector emissions in Mali. So we've calculated the number of households in the country based on the total population, which we've taken from the World Bank, divided by the average number of people per household. We can disaggregate between urban and rural, and because of the information in the demographic and health survey, we should also be able to divide Bamako from other urban areas if that would be useful. For the from the consumption of energy in households, we should be able to split cooking, lighting using kerosene. So we can have cooking fuels, we can have lighting using kerosene, and then the total consumption of electricity. we don't have enough information to be able to split electricity consumption between different appliances. We can just have it as a total. And then we have this data available 2006 to 2018. So let's look at an example for 2018. In 2018, the World Bank says that there were 19 million people in Mali, and 42% of those were in urban areas and 58% were in rural areas. With 6.1 people per household in urban areas in 2018, that gives us 1.3 million urban households. So that's calculated by taking 19 million people multiplied by 42%. That gives us the number of people in urban areas, and then divided by 6.1. That gives us 1.3 million households. And we can do the same for rural households to get the number of rural households. So we now know how many households we have in urban areas and how many we have in rural areas. Next, we have information on the percentage of those households in urban and rural areas with access to electricity, 84.7% and 38.2% in 2018 in urban and rural areas, and the percentage of households who use different types of fuels and technologies for cooking. So the majority of households use wood or charcoal for cooking, both in urban areas and rural areas. In rural areas, 90% of people use wood. In urban areas, 59% use charcoal and 35% wood. So we have the number of households using these fuels for these activities. To calculate the energy intensity, we then take the number of households, for example, with access to electricity, which is 1.334 million households, if you add them up between urban and rural areas. This is the number of households with access to electricity in 2016, the latest year that we have available for the energy balance. We have 1.3 million households, and our energy balance tells us that the total consumption of electricity in the residential sector is 75,000 tons of oil equivalent. That's the value right over here. Our average energy intensity, the consumption of electricity per household for just those households that have access to electricity, is then 74.66 million tons of oil equivalent, 1,000 tons of oil equivalent, sorry, divided by 1.334 households. So if I do 74,660, that's 74,000 tons of oil equivalent, and divide it by 1,334,420, that gives me the average amount of electricity consumed per household. And I can do exactly the same for the households using wood for cooking, charcoal for cooking, LPG for cooking, or kerosene for lighting. We've done exactly the same calculation, the total energy consumption divided by the number of households who use that fuel. Within LEAP, we then have default emission factors taken from the IPCC and taken from other emission inventory guidebooks for greenhouse gases and for air pollution. So these default emission factors have been included in the analysis as well. So now the key question is, how do we get this data into LEAP? The first key thing is to set up your data in a way that can be easily transferred into LEAP. And that's what's included in this Excel spreadsheet that we've shared with you. Within the Excel spreadsheet, we have all of the data from the demographic and health survey and from the energy balance. We have each energy balance included in this Excel spreadsheet. But the data is not in a way that's easy to enter into LEAP. So these sheets here called activity data and energy intensity try and put the information into LEAP in a way that can be easily entered and in a format that is easily understood. We have here all of our key variables, and the numbers in green are data that has been directly entered into this spreadsheet. So the total number of people here, this is the population of Mali taken from the World Bank. So the source is in column AB here, taken from the World Bank. This is the percentage of the population in urban and rural areas, again, directly taken from the World Bank. The household size, urban and rural, the number of people per household, was available for 2006 and 2018 in the Demographic and Health Survey. So these numbers are in green. These numbers here are an interpolation. We've interpolated between the value in 2006 and the value in 2018. We've then calculated the number of households that are urban and rural, and then the total number of households. And here we have information on access to electricity for 2006 to 2018 and the different cooking fuels. These are the percentage of households who do each of these activities, who use each of the fuels for cooking and for electricity in urban and rural areas. So we have all of this information. In the Mali residential spreadsheet, a LEAP dataset, sorry, we have created a data structure to enter that data in that Excel spreadsheet into LEAP. So we have created key assumptions under demographics that allow us to calculate the number of households. So to create a key assumption, and a key assumption is simply a variable we want to use in our analysis. We simply right-click and click Add and create a new key assumption. And then enter the unit. And that gives us a new variable. So we have added variables here for population, for the household size in rural and urban areas, for the population of rural and urban areas, and the number of households in urban and rural areas. So we can see here that the values entered here in LEAP for the population are the same as the values here between 2006 and 2019. We've entered them directly. The way that they have been entered in LEAP is using an expression or a little equation using a function called interp. Interp is a function that allows us to enter a year, 2006, and then a value, and then a year, and then a value, a year, and then a value. And what it allows us to do is, if we didn't have data for 2007, it would simply interpolate between 2006 and 2008. So the interp function interpolates between a value in a particular year and a value in the next year. The reason this is important is because when we want to enter the population into LEAP, There's a really simple way of doing it and putting it into that correct format. When we have all of the years lined up like this, we can right-click and click copy. I'm going to then delete what is there and right-click and click paste. I can then select the first year, 2006, and the interval every 1 year. And Leap then creates the expression for us. This makes it really easy to enter lots of data into Leap quickly by simply copying and pasting it from Excel. Let's do the same again with the rural household size. So the rural household size is here between 2006 and 2018. I'm going to copy it from Excel and I'm going to paste it in Leap. So now I have my rural household size and I already entered my urban household size. I then have the percentage of the population that live in urban areas here. But look what we've done for rural areas. We could have copy and pasted this value here, the percentage of households in rural areas. But we don't need to. We can enter an equation here that the percentage of the population in rural areas is 100 minus the urban population. So these two values will always add up to 100%, which is really useful. It makes sure we don't introduce any errors when we change these values perhaps in the future. So now we have our rural population decreasing and our urban population increasing in the same proportion. Our number of households in urban areas and our number of households in rural areas, we again don't need to enter. We can write the equation to calculate the number of households in each of these areas. We have the population multiplied by the urban population, this percentage, divided by 100, divided by the household size. And this gives us the same values as in the Excel spreadsheet, but it's calculated in Leap. Okay, so that's us entered our key assumptions, the key variables we're going to use in this analysis. Underneath demand, we now need to create our residential structure, the modeling framework to look at our residential data set. So our first branch is the residential sector, and the activity level there is set as the number of households. So we've selected the unit of our residential sector as the number of households. Under the expression box here, in the expression box, we then have an equation that refers to our key variables to put in the total number of households in Mali. And the expression is the urban households plus the rural households. We add up the number of households in urban areas and the number of households in rural areas to give us our total number of households. The next level down, we then have urban and rural households separated, where we want to enter the percent share of households who are in urban areas or that are in rural areas. And again, this percent share of households is not entered directly, it's calculated. So the number of households in urban areas is calculated as the number of urban households divided by the total number of households, multiplied by 100 to get it into percentage. So that gives us the number of urban households, or the percentage of urban households, sorry. The number of rural households is then calculated by subtraction. This function here called remainder 100 takes the number 100 and subtracts the percentage of urban households to ensure that this value always adds up to 100. So underneath residential, we first separate our houses geographically. Then we split it by activity, and we have 3 activity branches: cooking, kerosene lighting, and electricity consumption. And the activity level here is still the percentage of households, but it is a different type of percentage. It is the percent saturation of households who cook, the percent saturation of households who use kerosene for lighting, and the percentage of households who consume electricity. So we have assumed that all households do some form of cooking. So the percent saturation is 100 for cooking. For electricity consumption, we've entered in the percentage of households with access to electricity. We've entered in these percentages here. Again, by simply copying and pasting that value into LEAP. For kerosene lighting, we have assumed that it is only households without access to electricity that use kerosene for lighting. If you have access to electricity, then you use electric lighting. So the kerosene lighting is then 100 minus the electricity consumption. So it's 100 minus the number of households who have access to electricity. So that's what that equation is doing there. And we then have the same in rural households, the same activity branches. Underneath the activity branches, we then have the fuels that are consumed: wood, charcoal, LPG, dung, coal, and electricity for cooking, kerosene for kerosene lighting, and electricity, obviously, for electricity consumption. Where we have multiple fuels, we then say what percentage of households cook using these different fuels. Again, copying and pasting this data here into the LEAP dataset. And this gives us, then shows that in urban areas we have wood and we have charcoal that is commonly used for cooking. But I've made a mistake. This value here is actually for charcoal. So this graph here, one of the advantages of LEAP is that the graphs can show you where you've made a mistake. I noticed here that the amount of wood being consumed was going up in urban areas, where actually it should be decreasing. I can quickly fix that. I can copy this value here for charcoal, and I can paste it under charcoal, and then change wood to remainder 100. So now our charcoal consumption in urban areas is decreasing, and the wood consumption is decreasing. In rural areas, we have pretty much all wood consumption, 90% wood consumption. So this is our activity level. This is how we've entered the activity level and broken down households based on the fuels that they consume. As we looked at in the PowerPoint, the second part of calculating the energy consumption and the emissions is then the energy intensity. The energy intensity we've calculated by taking the total energy consumption from the energy balance. So if we look at the value for 2006, the total electricity consumption was 28,000 tons of oil equivalent. That's taken directly from the energy balance the electricity consumption in the residential sector. We then have the total number of households consuming electricity, which is 386,000 households. That's calculated by taking the total number of households here and multiplying them by the total percentage of households with access to electricity. Gives us the total number of households. Then, if I take my total consumption divided by the number of households, I get the energy intensity, tons of oil equivalent per household, 2006 up to 2016. I do exactly the same for cooking. The total consumption of LPG, of charcoal, and of wood, and the total number of households who are using LPG, who are using charcoal, and who are using wood. I divide them together, and that gives me the average consumption of charcoal or of wood per household for cooking. And if I do the same with petrol lampon, with kerosene, I get the amount of kerosene consumed per household. In LEAP, we enter it in exactly the same way by copying and pasting those values into the energy intensity, the final energy intensity branch or tab in LEAP. So I now have copied, for example, the energy intensity of wood, and I have pasted it in to give me my final energy intensity. That's all the data that I need to enter. The final level down gives us our emission factors for each of these pollutants: greenhouse gases, short-lived climate pollutants, air pollutants that are included in the analysis. So now I've entered all of the information that I need to be able to estimate the emissions for historical years between 2006 and 2018. If I click on results, I can then see those emissions. I can see where my emissions are coming from. So at the moment, I only have emissions under energy demand. Let's have a look at carbon dioxide first. I only have emissions for the residential sector. Eventually, we're going to have emissions for lots of sectors, and we'll be able to compare them. So for carbon dioxide, between 2010 and 2018, my emissions were between 80 and 140,000 metric tons. They were fairly evenly split in 2010 between urban and rural areas, but now they are much more in rural areas, in urban areas, sorry. The majority of the carbon dioxide emissions come from cooking and a little bit from kerosene lighting. And of the fuels, the majority come from using LPG and from kerosene. So I think it's important to point out that here, LEAP is not showing the carbon dioxide emissions from consuming wood or biomass, because they are assumed to be, they are biogenic carbon dioxide. They are assumed to not make a net contribution to CO2 emissions. The contribution to carbon dioxide emissions from using wood and charcoal is accounted for under the AFOLU, under the land use change part of greenhouse gas mitigation assessments, not the residential sector. If I look at another pollutant, for example, if I look at black carbon, an air pollutant and that contributes to global warming, we can see that the emissions are now more in rural areas than urban areas, and they are all from cooking. A little bit comes from charcoal, but the majority of the black carbon emissions comes from wood. So we're able to view some results in this analysis already, which is exciting. So we would really like your opinions and your opinion on the residential sector analysis for Mali for historical emissions. But we also need the experts to provide methodologies and assumptions about the baseline projection. We need to develop methods for projecting population, number of households, urban and rural split, access to electricity, and the fuel used for cooking. We need to project these into the future. There are different methods that we can use to do this. We can project using official projections for population or households if they are available from the statistical office. We can continue historical trends if we think that they're likely to continue into the future. We can use expert judgment. We can use your judgment to tell us what the trends are likely to be in Mali, because you know much more about the situation than we do. Or we can link the projections to key drivers like income or population changes and things like that. If we look at the historical trends, we can see that between 2006 and 2018, there was an increase in the number of urban households and a decrease in the number of rural households. Is that urbanization likely to continue into the future? The number of people per household is also increasing in urban areas and is flat in rural areas. Are those trends also likely to continue? The percentage of the population with access to electricity is only going up. In urban areas, it's at 85%. What we need to understand from you is that likely to reach saturation, to reach 100%? And if so, when is that likely to happen? In rural areas, it's almost 40%. Over the next 10 years, how can that be expected to grow? Is it going to grow linearly like we have here, or are there going to be, or is it going to grow in some different way? In urban and rural areas, there's been a switch over to using charcoal for cooking, but no large uptake of clean fuels like LPG or electricity. Is this trend in charcoal going to continue? And in rural areas, it's mostly all wood, and I think we could assume that, you know, mostly wood is going to be the dominant fuel in the baseline. For the energy intensities, we also need to project those into the future, but they are relatively flat, relatively stable. So the amount of energy being consumed per household for cooking or for electricity may be expected to stay relatively constant over time. So to finish this video, the residential sector model that we just showed you is good because it's relatively simple. It uses data from the demographic and health survey from the National Energy Balance. So it could be easily updated over time when those documents are updated. So it's maintainable, which is important. Can also be used to evaluate policies and measures where there is a switch over to different fuels or technologies for cooking and for access to electricity. The limitations of the model is it doesn't break down into different provinces or states or different geographic regions, only urban and rural areas. And to look at mitigation measures that are focusing on energy efficiency is difficult because we don't break it down by appliance. In addition, the energy intensity values are the average for the whole of Mali, not split by urban and rural. So we're just using an average energy intensity for all geographic regions in Mali. In terms of the next steps, SEI is going to record a YouTube video about the residential sector model. This is that video. What we would like you to do now is to identify the data or improvements to the model that we've developed. We'd like your guidance and advice on projecting population, household size, level of urbanization, and access to electricity into the future. We also need to learn from you, or to get from you, a list of the key mitigation measures that we want to evaluate in the residential sector. These can be related to residential cooking, energy efficiency for electrical appliances, access to electricity, and any other measures that will affect energy consumption and emissions in the residential sector. Thank you very much for listening. Please let us know if you have any questions. Thank you very much.